Hey everybody, Mr. Throne here. We're going to lead you through a little exercise, what's called the density lab, where we're going to be calculating the density of various objects, and we're trying to look at a realistic way to do this. The first thing I need you to do is look in your Schoology account. You're going to go to your physical science class, and you're going to print off density lab assignment. Okay, it looks like this. Mr. Radford's showing you what that page looks like. And if you have a printer, I want you to print this off. If you don't have a printer, or your printer is out of ink, you're going to get out a piece of paper and you're going to write this down and try to make it look exactly the way it does here. Try to keep it in the same format, as close as you can get to that. Okay, so take a few moments, pause this video, and get all your stuff ready. You're going to need something to write with, and you're going to need a calculator to do this activity. Okay, so after that happens, come back, start the video up again, and we're going to walk you through some things here where you're going to be taking some measurements and hopefully getting an idea of what would happen. Normally we'd be doing this together in a lab, but since we're not here, we're going to be able to do this virtually. All right, so we've got 4 objects here. All right, now hopefully you've got this page and you're ready to write a few things down. We got 4 regular objects. We got a block of wood, we have a marble, we got a fishing weight, and we got a bolt. Okay, just 4 random objects. We're going to try to measure the density of these and use the density that we calculate to identify what they would be made of. And really, this is experimental data, so nothing's going to turn out perfect, but it's going to give us a good guess. Okay, so the first thing we're going to do is we're going to try to measure the density of a marble. So I'm going to take a look at this marble. Right now, that's a sphere, and that's a nice geometry shape, but if I were to try to measure this, that's kind of hard to tell, like how far across. What's the diameter of that sphere? I'd have to eyeball it. So we're going to use a different method. We're going to use a method called water displacement, okay? If I drop this into some water, it's going to sink to the bottom and it's going to push that water level up. If I can figure out how far the water went from the beginning to the end, how far up it went, it would tell me how much space this takes up. And there's 2 things we need for density. We need mass and volume, okay? So first, let's go ahead and get the mass. Over here we've got a scale. Okay, if I put this on the scale and I try to keep it from rolling off, this says that marble weighs 5.1 grams. So I want you to write that down. I'm going to show you where. We're going to write down 5.1 grams as the mass. Okay, now I'm not going to do this for every one of these. You're going to write these down as we go, but I'm going to model for you where the information would be best put. Now, if I'm going to do water displacement, I first need to know which one of these to put it in. And the best option would be to put it in the one that is the smallest, but one that it will fit in. Okay, so if I try to put in this one, it'll fit, I believe, in all 3. I'm going to choose the smallest one because if you look at these numbers, they're spread out more. It's going to be easier for me to tell what's happening, okay, to see it. So first thing we need is that volume, all right? Mr. Radford's going to hold that up there, try to get as level as we can. We want to look for the bottom of the meniscus, which is that little dip. This kind of makes a U shape because of the properties of water. It clings to the walls. And if I read that, this is 5 milliliters down here. I go up 2 lines at 6, 2 lines at 7, 2 lines at 8, and it looks like the bottom of that meniscus is right at about 8 milliliters. Okay, that's my initial volume. So before I put anything in, I'm going to write that down. My initial volume is 8 milliliters. Now that doesn't mean this takes up 8 milliliters. It means that's where the water level is starting. I'm going to drop this in. I'm going to try to drop it slowly so that it doesn't break that glass too. Now you'll notice that went up. Okay? And we want to look for the bottom of that meniscus. And this is sometimes you have to do a little bit of an estimation. It looks like we're at 10 milliliters right here. And this second line would be 11, but we're not quite to 11. So we're kind of in the middle. I would say it's about 10 and a half. Okay.
10.
About 10. It depends on the angle you look at, and ideally you want to have this on flat surface. But this is the best we can get with our camera. So we're going to call that 10 milliliters. All right, so my final volume is 10 milliliters. Now the part you're going to do, you have to figure out the total volume of the object. You're really looking for the change. How much did the water level go up from 8 to 10? Okay, and in this case, just to model this for you, that's a change of 2 milliliters. What that's telling us is the mass of the marble is 5.1 grams, and its volume, just the marble itself, is 2 milliliters. Now your job is to do the density calculation, and density is equal to mass divided by volume. You're going to calculate that density, and you're going to keep it rounded off, round it off a little bit, but you're not going to round it off to a whole number. And you're going to put that right here. And that tells us about the marble. We're going to do this for a few more objects. Okay? So let's take a look at our next one. This one's a fishing weight. Oh, no, let's take a look at the bolt. I got to make sure I do this in order. Okay, this is just a bolt like you buy in the store, something used to fix things, and not all bolts are the same. Okay? Let's make sure we get the mass of this thing. So I set it on the scale. This is quite a bit heavier than the marble. It's 26.7 grams. So I want you to write that down for mass. Now I'm going to put it into a graduated cylinder. I could have used this small one, but when we started out with only 8 milliliters, the bolt wouldn't be completely submerged. I need something where it's going to be completely underneath the water. I'm going to set, let's tell you what, I'm getting ahead of myself. I don't want to set that in yet. Let's make sure we get the overall initial volume. Now this has a different scale. 20, 21, 22, 23, 24, 25. So it looks like it's right at about 25 milliliters. Okay? So my initial volume is 25 milliliters. Write that down. Now I'm going to put this in and get the final volume. And this should tell me how much that water level went up. 20, here's 30. It looks like I'm 2 lines below 30 at the bottom of that meniscus, so that's going to be 28 milliliters. So your final volume is 28 milliliters. Your job is to find the total volume, the change in volume of that object, just like we did up here. And then your job is to calculate the density. So make sure you have written down the mass, the initial volume, and the final volume. If you didn't catch one of those amounts, rewind this video, go back to that spot, and see if you can get it. Okay, now, let's move along and try a couple of other things here. You have a second side to this. We're going to take a look at a fishing weight. Now I look at these things and I go, which one should I use? I'm going to use the small graduated cylinder again. So I'm going to basically dump this out and put some water in. And a lot of people say, how much water should I put in? And the answer is yes. Put in some water. It doesn't matter how much it is, as long as it's enough to submerge the fishing weight. Okay, I don't care where it starts, I care how much it changes. Okay, so if I look at that, looks like we are at about 10, 11, 12, 13 12 and a half? 12 and a half milliliters.
Yep.
Okay, so 12 and a half milliliters. That's my initial volume. Okay, before I put this in, what am I forgetting? I'm forgetting mass. Okay, I need how heavy it is. I don't want it to get wet. That's going to change the weight. So the mass of this is 21.8 grams. Okay, so think about this, 21.8 grams, an initial volume of 12.5 milliliters. Now my final volume, I'm going to drop this in and try not to break that glass cylinder.
That's why he's putting it on sideways.
Yep, and so it slides in, it doesn't drop in. Okay, and that means we are going, it looks like we're right at about 15, aren't we? Is that what you see, Mr. Radford?
Well, that's even with it, so I think we're 14 and a half.
Okay, 14.5 milliliters.
Yeah.
All right, now this nice part about having this on video is you can always go back and replay it and get some amounts you might have missed. Final volume is 14.5 milliliters. Your job, calculate the overall volume change that represented the weight, and then do your density calculation.
Please make sure you show your work.
Yep, that's what the space is for. Show how you set it up and where the numbers go. That way if something is wrong, we can figure out what went wrong and how to fix it. Okay? Now you notice I didn't use the big one. I could have. But the scale is so compressed down on the big one, it's hard to see the changes, okay? So I want to use the smallest thing possible because it stretches out that scale and I can get better readings, more detailed readings. Our last one here is a wood block, okay? This is just a chunk of 2x4. Okay, but if you've ever used a 2x4, you know it's not exactly 2 inches and it's not exactly 4 inches. Okay, it's always a little less. So we're going to do this a different way. You're going to be using some geometry for this one. I can't fit it inside one of these graduated cylinders. Plus, this floats, it doesn't sink. So I need a different way to approach this. I'm going to measure in centimeters and I'm going to get the length, the width, and the height. And that should be able to get me the volume of this block. So the length of this thing looks like it is about 14.5 centimeters. 14.5 centimeters. So for length, put down 14.5. The width looks like it's about 8.5 centimeters. So 8.5 centimeters for the width. And then the height looks like it's about 3.6. 3.6 centimeters right here. Now you're going to use a little bit of geometry. There's the formula to calculate the volume of this block. It's going to have a lot bigger volume than the other things you've been working with. But then we're going to have to take the mass and we're going to figure out density. So let's see if we can weigh this thing. This weighs a lot more, 178, boy, it's jumping around. Let's let it level out. 178.3 grams. Okay. So 178.3. You might say to yourself, that's way heavier, why is it float? But it also takes up a lot more space. So we remember density has both things involved, space and weight. Okay. Now, the last thing here that we're going to do, you'll see below the calculations you made, I gave you a list of different densities that, here, I'll show you right here, different densities that you could look up. You could Google those and you'd find out those are the accepted value. It's been measured so many times, you kind of get the same thing every time, and we know what these densities are. They can be used to identify some of these things. So you're going to use your density, for example, the fishing weight, compare it to these densities and see if you can come up with your best guess of what that fishing weight is made of based on the density. It won't be perfect, but it'll be close. It's experimental data. We're looking for patterns. We're looking to see what it's close to. Okay? Use this video as a way to go back, scroll back through it and pause it at different points and get the data off of there, do the calculations and show your work, and then take a picture of this and send it to your teacher.